Hello everyone. Today we're gonna learn about chapter 4 and 4.1, right? Chapter 4 it's about correlation and regression. So 4.1 it's about correlation, and 4.2 it's about regression, and 4.3 it's about residual. Okay, let me talk one definition here, then we can move on. So we have the data collected from one variable we call univariate data, right? And we have two variables, then bivariate data. All right? So your homework can indicate that bivariate data. All right? All right. So 4.1, we have a scatter plots and correlation. We have a learning objective here. Oops. All right, so let's talk about terminology here. When two variables are related to each other in some way, we say they are associated. Yeah, so previously we talked in the observational study, they are associated, right? Association rather than causation, right? And we have correlation here. So an association between paired quantitative variable is called correlation. So two variable must be quantitative. So numerical number related to each other, right? And we talk about the bivariate data earlier, two variables are bivariate data, right? So in that case, the two quantitative data, all right? All right, so we have a definition here. Bivariate data consisting of two quantitative variable. In that case, paired. So we talk about the X and Y. Then the X and Y, we called X as explanatory variable, and Y is response variable. All right? X and Y is response. Okay, so in that case, we have explanatory variable. Also, this is a predictive variable. And we have a response variable. We might think that is the outcome. Yeah? Okay, so previously, when we talk about design the experiment, we also have explanatory variable and response variable, right? That means cause and effect. Correlation is not cause and effect. It's about the association. And we have still explanatory variable, which is the predictive variable, and then response variable. Make sense? All right, so we have example one, making scatter plot. So we have data set. We want to make a scatter plot and interpret the relationship between the grades on exam number one, which is the explanatory variable on exam two, response variable. Yeah? Okay, so this will be X, this will be Y. So if we are using like order pair, so X, Y, right? So this is X, this is Y, which is, this is explanatory variable, right? And then this is response variable, right? Okay, so there will be 70, 81, and 95, 87. We knew 80, 82, 83, 79, and 82. 90, and 10, 76, 0, 73. Yeah? Okay. Now I want to draw two dimension like X and Y, right? Okay, let me make a scale here. All right, I made a scale, see here. So let's plot the point. The first one is 70 and 81. Oops, 40 is missing. 70, 74x, and 81. So approximately here, oops, approximately here, right? Okay. Basically, scatter plot is the same as a dot plot, but dot plot with scatter. Yeah. So normally dot plot we have a dot and then vertically arranged, right? But the shape is just a dot, but then scatter all over the place. That is a scatter plot. Make sense? Okay, 70, 81, 95. So this is 100. So 95 in the middle and 87. Ooh, it's hard to see, right? So let me do over here. Yeah. Okay. Third one, 80, 82, 80, 82. So it's over here. 83, 79. It's over here. And 82, 90, 82, 90. It's over here. And 1076. Yeah. Jackson 1076. 1076. And 070. So this is 0, right? 073. Yeah. Okay. That is a scatter plot. Make sense? All right. So what is the pattern trend? So pattern trend looks like that, right? So like that means looks like when x is increasing, y is also increasing, right? So we call this is a positive association. So we're gonna get into that more later on. So positive association. All right. Now I'm gonna show you how to use a StatCrunch. All right. So now we have linear correlation, the shape. Yeah. Let me talk about the perfect, and then I introduced you earlier the positively associate, right? Okay. So let's take a look this one first. So this is a positive, but then can you see that only one straight line, right? So we called this is a perfect, and this is a positive correlation, or we said positively associated, right? Okay, perfect. And looking at this one too, all the scatter plot is going this way, increasing, x is increasing, y also increasing, right? So this is also positively associated, right? All right. Then looking at this one, yeah, when I teach this one, I always say to students, make a rectangle in with the scatter diagram. Then this is a strong and then positive correlation. All right. Okay. So this is a scatter, the dot plot with little bit scatter, right? Yeah. And this is a perfect. only one line we can draw. This one we need a rectangle. Yeah. All right. Now we have a moderate, positively associative, and then positive correlation. So we draw the rectangle with the scatter diagram. Then that rectangle is getting bigger, right? Bigger than this. Yeah. So this is a moderate. All right. Let's take a look that way, right? Yeah. My side from my end. Yeah. That way. So let's take a look. This is a perfect negative. And then this is a strong negative correlation. And then this is moderate negative correlation. Yeah. All right. So positive, negative, we might think about the slope. Positive slope, negative slope, right? Positive thing, positive slope. And then negative thing, negative slope. Okay, so this one looks like parabola downward, open downward, right? Thing, parabola, open downward. Yeah, so y equal to x squared, right? Okay, so they say the nonlinear correlation. Yeah, so that is a nonlinear. We called this is a linear. This is a linear, right? Yeah. Draw the rectangle. Also, we call the linear. Yeah. So extend of the straight line. Yeah. But this one is not linear. Yeah. Okay, how about this one? This one, we said no correlation there. Yeah. So we are talking about correlation between two variables, right? Linearly this one, linearly this one, linearly this one, linearly this one, linearly. Negative, positive, right? Yeah. So this is a nonlinear correlation. There is a correlation exists, but not linearly, right? Means that this is a correlation at all. Yeah. Is it clear? Okay. So yeah, they talk about that. Positive slope, negative slope too. Now we have example here. Data was collected from fast food meals from several restaurant chains. Two of the variables were total fat in the meal and protein in the meal. Okay, so this is a total fat, this is the protein, right? All right, so scatter plot. And then describe the correlation between the variables. Okay, what do you think? Did you have a dinner? Did you have a lunch? Looks good, huh? Okay, first of all, is it positive or negative? Very good, it's a positive. It's a positive because the trend goes this way, right? Yeah, it's a positive. Then what do you think? Is it perfect, strong, moderate? What do you think? Okay, so review. This is a strong. This is a moderate. What do you think? Uh, if we draw the rectangle this much, right? The scatter plot is their trend is gathering here, right? Isn't it? Yeah. What do you think? Between strong and moderate? Yeah, because this one is off. And then when you have a strong is a little bit nicer. And then little rectangle we can make, right? Yeah. Okay. Well, what's the best way? Approximately strong, but it's not the moderate, right? We can see that. Positive, approximately the strong correlation. How about that? Positive, strong, approximately, right? Correlation. Yeah, it's okay. All right, next one. Let's take a look. Before we take a look this one, look, they say that terms weak, moderate, or strong is subjective. Yeah. So yeah, right. So I was right. I can say that between strong and moderate, right? Yeah, more than moderate, but it's a little bit less than strong. Yeah. Okay, anyway, let's do this one. Can you please try this one? This one we can see the negative, right? The trend is negative, but definitely we can see that that is strong, right? Yeah. So negative, strong correlation there, right? Correlation. What about this one? Can you see that? Let me make it bigger. Yeah. So this one, what can we tell? Yeah, the scatter plot is all over the place. Yeah. So we can say that there is no correlation, right? Like this picture, right? Where it go? This picture. Yeah. There is no correlation like this. Yeah. Okay. Uh, hold on a second. No correlation, right? Okay. Okay. Now, how they find the correlation then? Yeah. So let's take a look. Okay, so we have computing correlation. So there is name. We can use linear correlation, or some textbook indicate the Pearson correlation coefficient. But it's too long, so correlation or linear correlation or linear correlation coefficient. Yeah. Okay. So then we are using R. So we don't do population correlation coefficient. We're doing, this is a sample linear correlation coefficient. This is a sample linear correlation coefficient, yeah. Okay. They have a population correlation coefficient is rho, but we don't do that, okay? So only we do sample. All right, then the sample linear correlation coefficient, we indicate the R. Okay, now how do we using this? Yeah, so it's a summation of G sub X. All right, we knew what is the Z-score formula, right? Z-score formula, we had X minus X bar over the standard deviation for sample, right? Yeah, that is one. But then we multiply by G sub Y. What is G sub Y? We never heard that, right? Since this section, we talk about two quantitative variable. So basically, what is a correlation? Correlation means we have association with the two quantitative variable is correlation, right? So since we deal with two quantitative variables there, we have to have X, we have to have Y. X, which is explanatory variable, Y, which is responsive variable, right? So predict outcome, right? Okay. Now, so we multiply together by order of operation, right? So we multiply together and then we add them afterwards and divide by n minus 1. So n minus 1 again, we call the name of n minus 1 is degree of freedom. I told you, this one has the name, degree of freedom, right? Okay, then when did we when did we use n minus 1? Right. So when we talk about sample standard deviation, right? So if we are using n minus 1, that is, we can best estimate the population parameter, right? In that case, this is a sample linear correlation coefficient. So if we are using n minus 1, we can make a best approximate estimate the population linear correlation coefficient. Make sense? Okay, now we talk about the positive, negative earlier, and then we talk about the strong, moderate. Yeah, also if we have a strong, moderate, then they must be weak too, right? Okay, now if we have R, how they telling us? Because we knew the picture, trend, pattern. Yeah, we learn what is the positive, what is negative, what is strong, what is moderate, right? What is non-linear, what is no correlation, right? Then if we have just R by itself, so R, we calculate this is number, right? So this number is telling us also positive, negative, and strong, weak, moderate, right? So, make sense? Earlier, we had a scatter plot with a trend pattern. We can recognize with a positive, negative correlation, and strong, moderate, weak, right? Or nonlinear, or nonlinear and no correlation. Yes? Okay. Now, the R always between -1 and +1 because it's perfect, right? Perfect positive, perfect negative correlation. We had that earlier, right? And then if -1, I just said the perfect negative linear correlation, and R equal to +1, there's perfect positive linear correlation, right? And then when R equal to -1 closely, then strong negatively. When R is close to the +1, that's strong linear correlation, right? When R equal to close to the zero, there is weak linear correlation coefficient, right? Okay. All right, so earlier they said that when r equal to close to zero, then there is a weak linear correlation exists, right? We had that earlier, right? Weaker, close to the zero, right? But then if r equal to zero means there is no linear correlation. Make sense? Yeah. All right. It's linear. They said it does not necessarily mean there is no correlation. And then with the picture nicely, they shows us this part when r equal to zero, no linear, right? No linear. And r equal to positive 1 is perfect. We saw earlier, right? And then this is strong. Yeah, make a rectangle strong. And this is a weak. Yeah, right? So I can tell maybe 0.4567. Yeah. Okay, this is a negative part. Perfect. And strong negative. And this is a moderate, right? Did I say weak earlier? Yeah, it should be moderate, right? Moderate, yeah. Moderate. And this is moderate, right? Yeah. Then weak, more scatter, right? We can tell. Yeah. It's about r equal to negative 0.2, negative 0.3. How about that, right? Yeah. Okay. Now we want to calculate, but I want to show you by hand first, but it takes a lot of time. Can I use just a little bit data set and show you how to using by hand? Yeah, let me find out. Okay, now let us talk about whether this is a positive or negative correlation. All right, so we have, hold on 1 second. Let me copy one more time. So we have hours of study versus exam score. What do you think? Positive, right? So positive correlation. How about hours of TV watched per week versus GPA? Negative? Good. How about height versus weight? Positive. Good job. How about amount of exercise versus body fat percentage? Amount of exercise, body fat. Negative, right? Yeah, negative. Good. How about cell phone brand versus blood pressure? Huh. No correlation, right? So no correlation. So we understand what is correlation, right? Positively, negatively, no correlation in word. Okay. As I told you, I want to show you by hand how to find linear correlation coefficient. We are doing sample, right? We don't do the population. But then it's a lot of work. So I'm going to just explain to you how to use by hand from my previous lecture note. Yeah. Okay. Then we are using StatCrunch. All right. Okay. So this is the one. Actually, this one come from your homework. So this is the information, right? So there is a formula. So we have g sub x times g sub y, and then we make a sum divided by n minus 1. Yeah. All right. So in order to calculate by hand, we have to have mean of x bar, mean of x bar, mean of x variable, and standard deviation of x variable, which is explanatory variable, right? And we have a mean of y variable, I'm sorry, standard deviation of y variable, which is response variables, right? Okay, those information we have to have in order to find the sample linear correlation coefficient calculation by hand, right? Okay, so here we go. Oh, I should erase. Okay, so here we go. So g sub x, yeah, g sub x, calculate individual 4, 2, 1, 3, 8 by using that x bar, s sub x, right? And then we have y sub I, so 3, 2, 8, 5, 4, and then we calculate g sub y, right? Like this. Okay, now we multiply g sub x times g sub y, which is this formula, right? Yeah, we multiply, then we get that. All right, then we have a summation of that, right? So we make a sum, which is g sub x, g sub y, right? Summation of, how about that? Summation of, okay, then we get negative 1.319. So we have a negative 1.319. How many n? We have a 5n. 1, 2, 3, 4, 5. We count it this way, right? We not count 1, 2, 3, 4. Yes? Okay, so only 5. 5 minus 1. We calculate negative 0.3297. Okay, let's check the answer with the StatCrunch. Check it out. This is my word all the time. Check it out, right? Okay, let's check. All right, so I wrote down the StatCrunch number here. Okay. All right, so we can say that week. Yeah. Negative weak correlation. Yeah. Okay, how about this? Let's just take a look from the textbook. Yeah. So we have exam 1 score, exam 2 score. Then using StatCrunch, we have a 0.81 for strong, right? So we can say the strong. Yeah. Positive strong correlation. Okay. How about this one? This one has total fat versus protein. So, oh, looking at this one, 0.8, also positive strong. All right. How about this? It's miles per gallon versus weight. So we get negative 0.88, negatively strong correlation, right? Yeah. So let me see. Strong negative correlation. Good. How about this? This is HDL level versus heart rate. So HDL is a good cholesterol. Yeah. So we get 0.04. 0.04. Yeah. It's close to the zero, right? So we can say that no correlation, right? Yeah. All right. R equal to 0, no correlation. R equal to close to 0, there's no linear. Sorry about that. Let me clear. So very close to 0, right? Then there's no linear correlation. Make sense? So can you see that? R equal to 0, then there's no correlation. Let me write down. Note. R equal to 0, no correlation. But R is close to 0, there's no linear correlation. Make sense? There is correlation, but not linearly. Clear? Okay, good. All right, now let's talk about the significant correlation and sample size. Okay, so what we are learning in this case, so I showed you earlier, when equal to 7, right? So we had, for example, let's just follow the textbook. If we have n equal to 45, and then the correlation equal to R equal to 0.72, which is moderate, right? Moderate correlation, positive, right? And is it same as when n equal to 7, we get moderate 0.72? Do we trust that? Because when n equal to 45, it's a sample has enough to show that the pattern, right? Linearly positive associated, right? But then when n equal to 7, the few two, the scatter plot make a pattern is not clearly, right? Accurately, right? So small sample are not as reliable, right? Then what we are doing, so we have correlation between two variables. We have a terminology, the statistically significant if there is enough sample evidence to conclude that there is a linear relationship between the variables. Make sense? So we have a R equal to 0.72. Is it enough sample evidence to make that conclude is moderate, positive correlation, right? So then how do we check that? Let me bring that guideline. Okay, so this is the guideline how to check whether that correlation is a statistically significant or not, right? So let me highlight statistically significant. All right, so we have a correlation R, right? Then we take the R as an absolute value. That means we compare only the number because correlation is number, basically. It gives us direction and strength, right? So direction means whether go to positive or negative. Strength means is it strong, moderate, weak, right? Okay, so if we take that correlation, take the absolute value, what does the absolute value does? Gives us only the positive number, right? So we compare only the numbers. How do we compare? We compare with this critical value with the same sample size. Yeah? Then let's take a look. If the original data set R is greater than the critical value, this critical value, Then we say that the correlation is significant. What this mean? This means there is enough sample evidence to conclude there is a linear relationship between two quantitative variables. Make sense? Yeah. So if not, there is no linear relationship between two quantitative variables. So we remember only one thing, R is greater than the critical value. Okay? All right. Let's do example so that we fully understand what is statistically significant. Okay, so let's do this example. So first one, second one, and then you try two, and then I want to make one more. A, B, C, D, E. So you try two, right? And then let us do A, B, E. So R equal to point. Let me make one. 5, 1, 2. Yeah. In sample consisting of N equal to 51 data pairs. Yeah. How about that? Sample missing. Yeah. Okay. So you try CD. I will do ABE, right? Okay. So let's try A. So we don't have to take the absolute value, right? So just a 0.647. Let's take a look. Sample size N equal to 35. Can you see that 35 is this one? So that is 0.334, which is a critical value. Yeah, let me denote it this way. All right. Then what do you think? The correlation is greater than critical value? Yes. Yeah. Then we can say that there is the statistical significant, right? Correlation is significant. Either way, we can say that. Thus, the correlation is significant. Yeah, or statistically significant. Yeah. Okay. Second one. What do you get? R equal to negative 0.412. So we have to take the absolute value, right? So absolute value, that means 0.412. When n equal to 16, so 16 is here, which is 0.497. So which one is bigger? The critical value is bigger, right? Then we can say that there is no, right? Correlation is not statistically significant. Yeah. Correlation is not significant. Okay. How about E, right? So you try CD, and then I want to do E. So R equal to 0.512 is positive, so we don't have to take the absolute value, right? And then, n equal to 51. Look, we have only the 50. 50 is the last one. For n equal to 51, then we are using this one, n equal to 50. Make sense? So above, when sample size is more than 50, we are using just n equal to 50, just pretend. Make sense? So we are using that. So 0.279, which one is bigger? This one is bigger. So we can say that the correlation is significant, right? Okay, let me write down note. If n is bigger than 50, let us use n equal to 50 in the critical value table. Yeah? What is the name? Table. Yeah. Right. Make sense? All right. Okay. So now we have correlation and causation. We talked earlier, right? In the beginning. So correlation, we have explanatory variable and the response variable. And then what is the definition of a correlation? Correlation is association, right? Association with two quantitative variable, right? So let me write down. All right, I wrote down here. And then correlation, we are learning only the sample, right? So sample R gives us, R is telling us direction and strength, right? So direction, which is positive or negative, right? Sorry, no space, so I'm writing this way. And then strength, how strong? Strong, moderate, 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 right? Not the moderate, and weak, right? Or no linear, right? Okay. Causation, we talked in the the designed experiment, designed experiment or experimental design, right? So we talk about the cause and effect. So we don't talk about the cause and effect in correlation, right? So it's association, right? We talked. Yeah. So let us read that. When correlation exists between two quantitative variables, we know that is related. However, we must careful not assume that one factor causing the other. Yeah? So we should not do that. Let me underline here. Not assume that one factor is causing the other. Yeah? So they talk about the unemployment rate for Black and white American from 1990 to 2020 positively correlated with R equal to 0.9, which is very strong, right? Yeah. So when the unemployment rate for one group is high, so is the other. When unemployment is lower for one, it tends to be lower for the other two, right? So one is high, one is other one is high. One is lower, other one is also lower, right? It does mean that one. Let me underline. It does not mean that one of the unemployment rates is causing the other, right? It's not. They are underlying factors in economy or lurking variables. So we talk about the lurking variables, confounding variables, right? Remember? So confound. There's other factors include that study too, right? So confounding variables. So what kind of confounding or locking variables make that are causing both to rise or both for together? What do you think? Okay, so I wrote down here the confounding variable or lurking variable, we might think about the economic, right, condition. So what kind of economy we can have that to make both rise or both fall, right? Yeah, this is a fall, yeah. Recessions, inflation, right? Yeah, this make a fall. And then policy change, it might be better policy than goes up. Yeah. Labor market shift, right? So policy change like during COVID-19, we had unemployment benefit and the COVID-19 paycheck protection program, right? So uh, the employee still can pay, right? Can get the paycheck. I meant, all right. And then labor market shift, uh, healthcare during COVID, right? So healthcare, hospital, and tech company, their growth, right? Yeah. And then important points, correlation does not establish cause and effect relationship, right? So correlation is not causation, it's association, right? Yeah. Okay, so we are done for this section. So let us talk about next section next time. 4.2 about the regression. All right. Thank you very much for watching. I will see you next time. Bye.